I'm going to present about the project that my team and I made for the program Advancing Machine Learning from Holberton School, Colombia. Our project is about COVID-19 radiography detection. So first of all, our team is informed by Oscar Rodriguez, landing page design and machine learning code development, Samir Millan, dataset recollection and machine learning code development, and Diego Quijano, backend and deployment of the project and machine learning code development. A short description from this project that I'm going to give is that this project attempts to detect through the use of data and image analysis tool in the field of machine learning, such as convolutional neural networks or deep neural networks, the detection of COVID-19, SARS-CoV-2 in chest X-ray images. The technologies that we use were Python as programming language, Jupyter Notebook for code review and step-by-step process, and TensorFlow and NumPy as libraries from Python. A report of the development. Some successes that we can give is that the principal improvement from initial 85 accuracy to 92 accuracy that could be a child. A failure that we have, it was the hyperparameterization was used, and that is why a slightly higher precision than expected is given. What can we improve? We can improve the precision by using a larger data set for better analysis. And what did we learn? Actually, we learned a lot of new things of how can we manage the data and in the best way. What's the next steps of this project? What we want to do is to check that the model can be even more accurate and thus use other type of images with comorbidities such as pneumonia. It's like improve all the project and give better examples with some other images. What were the ethical implications that we note on this? The most important ethical implications is that this tool is supposed to be used as a support for COVID-19 diagnostics. It is not intended to be the primary source to defend whether a patient has it or not. For this reason, the analysis has to be bigger than a COVID-19 test, symptoms review, and medical record. So what we say is that even with all these tools that we can give to doctors or so, to detect this COVID-19, COVID SARS-2, the doctors in hospital clinics, they have to do the test for this virus. And the summary conclusion. This was a great project which led us to put into practice all our knowledge given in machine learning, and in addition to being able to learn several new topics and the use of technologies created for machine learning to obtain all its benefits. Thank you, everyone. This is the end of the presentation. Good afternoon. Now I'm going to talk about the project like in pass by pass. For this project, we use some libraries. Actually, the main libraries we use were sklearn for image processing, NumPy for data processing, Matplotlib for graphic processing, and the TensorFlow to build and train neural networks, which allow detecting and deciphering patterns and correlations. Well, for this project, we are going to use convolutional neural networks to try to detect the presence of COVID on a chest, on an X-ray chest. This set has more than 7,000 images between normal images and healthy patients, and healthy images with patients with COVID. We are going to tell to the model if if the images that we are seeing are from normal images or images with COVID, then we are going to create an algorithm with Python that is capable of collecting the images from this folder, and depending on whatever is in normal or it has with COVID. For this, we prepare two arrays, one that we are going to call X and the other that we are going to call Y. Then we are going to perform a for, and we are going to go over the list of directories that we have a folder to. We have two folders, one that is called what is for train and the other for test. If the name of the folder that we are going to use is with the normal, we are going already preparing a label variable with the value 0. If the name of this folder that we come across is with COVID, then we have a label variable with a value 1. Or in the case that is not any of those cases, which is not going to happen, we would have a label with a value equal to 2. Well, for this, we are going to transform the image into a NumPy array that we add the image to X, which is the array that we have previously defined. And finally, we are going to add the label that corresponds to this image that we have prepared with a label variable, depending on the name of that folder. When that variable that we create above, that is going to come from the load images, is equal to true, it help us to load the images to the array using the get data, the function the get data. If we don't have to do all the process mentioned about, because we already have the files created. Then we will put the variable load from the load images into false. Now I'm going to show an histogram. Well, we have this histogram, and at the same time we see the radiography next to it. There are some that see in the 0 position of the pixels, or rather when we see completely black pixels. Sometimes there is a very large distribution, and there is certain amount of pixels built up, and here there are more than 400 pixels at 0, and it is normal because we have black areas of the X-ray on the sides. We have some useful functions for this that help us to check that everything is working well. The first one is plot 3 images that help us load 3 random images and we see that they are okay. Then we have 2 other functions that allow us to see the images of the normal and the COVID folders to check that they have been well recorded. Subsequently, we use a Seaborn library to confirm that we have balanced the normal labels and the COVID samples in terms of the number of samples in each set. Well, at the end, we're going to show some results that are loaded. As we see here, there are about 20 times that is charging all the model. In each time that pass, we can see that it can grow, or it can be lower at the next time, showing us a percentage that might be about the 80 accuracy, or even until 94 accuracy that we can show, 92, 94 accuracy. And that can show us that all the model is actually working as we expected, a little higher, I guess. It's been the hyperparametrization that gave us like reaching all that climb that in the 94 accuracy. And that's all I have to explain. Thank you everyone for this model. Will wait for us to pass color images to hit, but our image is in black and white. The tree means that a layer for each color. First, we are going to retransform our data sets, at least that the forms that the data has, the image will be the same. But what we do is declare a new variable for both the train and the test using a reshape that we create with xtrain reshape and xtest reshaped. We now proceed to declare our convolutional neural networks. We create the model variables, which is model sequential. This is to declare the model first that we use with COP2D from Keras, with a large filter of 64, with a 343 filter size, and with the ReLU activation function, which is for images. Finally, the shape of the image that we already know is 150 and 150 and 1. Then comes the max pooling 2D that we have made the most of it once we had taken this new image with the filters applied, and I'm going to have 64 of this characteristic map to the characteristic map, and I'm going to go through it, but I'm going to do it by max pooling. So here we specified a tuple to determine the dimension that have a little window that is going to go through it. And it's going to have the characteristic map, extracting the main characteristic, making a maximum values. We would already have a step made of convolution pooling.